All right, so I'm going to be demonstrating how I figured out how to do some of these problems. What is it? Multiplying or dividing trinomials by uh, binomial, I think it is. I don't know. I'm not a genius. So we're going to start out with the first two, right? And they're a lot simpler than the last three that we're going to do. So we're going to start out. This is the one that we're starting out on is x squared plus 9x plus 20 divided x plus 5, right? And I don't know how my teacher how she did this. She did it with long division. I was just like, that sucks. I'm gonna figure it out myself, you know. So I'm gonna start out by I noticed in every answer that she had, this was always a solution. So that's what one of my first step comes from, which is x plus 5. Now you got this other one over here. Now what's that gonna be, right? Like, who knows? Well, I know over here is x squared is going to be part of the equation. Well, how do I get x squared? Obviously, there's going to be two x's. But then that leaves your last digit. Now that we know all of this, we know how we can kind of calculate what this end part is going to be. And basically, it's like whatever adds to 9 and multiplies to 20. So 5 plus 4 equals 9. 5 times 4 equals 20, right? Oh, easy peasy lemon squeezy. All right, so let's get to the next one. And I haven't rehearsed any of this, so you're going to hear all of my jumbled mess. We have a squared minus 2a minus 35 divided by a plus 5. And if we apply the same mathematics or the same strategies, patterns that we did beforehand, right, we're going to know a plus 5 is going to be the first one, right? Easy, very easy. Well, we know a squared, so a has to be part of the equation somewhere. Ooh. What times 5 equals 35? 5, is 5 times 5 is 25. 7? 7? Negative 7? Would that be it? Because 5 times negative 7. Oh, God, I'm so bad at math. I'm so bad at basic addition here. Um, 5, 10, 15, 20, 25, 30, 35. Yeah, negative 35. And then 5 minus 7. There's a difference of 2 between 5 and 7, so that would equal negative 2, right? So that's correct, right? I think. Maybe. Maybe I'm just an idiot for the whole world to see. Who knows? Let's get to the more complex ones. I have not. Well, I. Can my camera focus? I haven't tested this one at all with the equations. We'll come back to that one last after I like refresh myself with all of this. But let's start off with the one that really just got my nuts in a twist originally here. You want to focus for the pen? Thank you. All right, we'll start with um x squared plus 10x plus 18 divided by x plus 5. This is where it starts to get a little complicated because she was like, "Oh, you can't do it that way, the way I just showed you guys, for this because it's going to have a remainder." And I'll show you how to deal with that here. So like I said, x plus 5 is going to be the first one. X plus 5, right? X squared here, so we know there's going to be an x in this one. What goes here, right? Well, if we figure out what adds to 10, right, would be 5. So 5 plus 5 will equal 10, right? But it doesn't add to 18. As you notice, 5 times 5 is not 18. It is 25, right? But if you take 18, right? But what is the difference between 18 or 25 to 18, right? Negative 7, right? You subtract 7 to get to 18. So your remainder, negative 7, right? And I don't even know how she even wrote her answer. I think it's like just x plus 5, right? Like this. And there's a plus in the middle here, and then there's just, this one's just over negative 7. I think that's like the proper way to do it. I have no idea. I didn't pay attention, you know? I just, but yeah, the negative 7 is how we got that. And I'll show you another example here. By the way, when I did this, I didn't look this up on the internet. I sat there and constantly pondered the patterns that I noticed until I was just like, hey, wait a minute. And I finally figured it out. And it took me like so long to put pen to paper to do it repeatedly. So we'll do the next one. 2x squared plus 5x plus 8 divided by x plus 1, right? Okay, x plus 1 is going to start out, right? We know there's a 2x squared. Now this one's a little different now. We know the 2x squared. Well, in order to get 2x squared, we need 2x. Then what? Plus what, right? Well, we're going to have 2x plus another x to get to 5x. So we already have our 2x. So what 2 plus what equals 5? 3. We got this 1 here. So 3. Oh, I guess, well, it's not the 1, but the x here is going to turn this into 3x, right? So when you finally draw this out, you'll get, 2x squared plus 3x plus 2x, right? Plus 4, right? And that's not our actual normal equation up here, right? It doesn't work. So we have our binomials, but how do we get to this 8? Well, if you do these two down here, the two that don't have the x's next to them, right? You get 3. 1 times 3 is 3. We can all agree on that, right? Well, how do you get 3 to 8? Well, 5. There's your remainder, right? So then your final answer, x plus 1, 2x plus 3, excuse my sloppiness here. These are supposed to be, would just be your remainder of 5. I think that's how you write it. I absolutely do not know. But let's go over that last one here, because this is the last one I tested to see, because 2 times doesn't mean it's necessarily a pattern, but this is the one where I was kind of like really confident about it. We got 2x squared minus 17x minus 38 divided by 2x plus 3, right? Okay. We got our, 2x, 2x plus 3 is going to be our starting, right? We know there's a 2x squared, so the next one is going to be x. And then what do we figure out now, right? So we know 2x. So we're going to have gotta get to negative 17. So I see what I see. Okay, so basically we're going to have 2x. This is going to turn into 3x, right? So we're already going to know that we have 3x because, this is our setup. We know this is, so we know this is going to be part of this solution. So that means we're going to be left with 3x, right? So we need negative 17x, right? And we have 3x, right? Well, what plus this equals negative 17? Well, negative 20, right? Negative 20 plus 3 is negative 17. So I see we have a 2x here. So this isn't actually a plus anything. This is going to be a negative 10, right? And then we combined it all together. We got negative 20x, right? Plus 3x. Why am I crazy? 2x squared, right? I did it backwards. I always screw this up. I don't know why I do. So we'll start 2x squared, negative 20x, right? Plus 3x minus 30, right? Oy. There's our negative 17x, right? Negative 17x. So if we got our we know that's correct, but then negative 30 is over here. That's not 38, right? Well, what's the difference between negative 30 and negative 38? Negative 8, right? Now, I don't actually know the answer to this one. I don't know what she had for an answer, so I'm just assuming based on the other two that the actual solution to this would be this pair of binomials here, negative 8, right? I mean, I could be completely wrong, and I'm just an idiot, but the one I haven't done yet, and I'm afraid to because I haven't rehearsed it, I haven't done it enough to, but I'm going to try to do this one because I don't know if this one's the one that has going to have a remainder. Well, let's figure it out. So, k squared minus 7k plus 10, right? That's a trinomial divided by k minus 1. Well, we start out k minus 1, k minus 1, doot doot, and then we're going to have, we know this one's going to be a k something. We need negative 7. Negative 7. We already know that negative 1k. Would it just be 7? Would it just be 7? Because we need... No. We're going to be adding them together, right? Adding them together? Would it be 6? Okay, squared. I haven't done this one before, like I said, so plus 6. What do you add to negative 1? It's going to be plusing, right? So it's negative 6? Right? Negative 6k. Negative 1k. That together is going to be negative 7 then. So we got our negative 7k from that. And if again, I don't know the answer to this, so this could be completely wrong, but if we multiply 1 times 6, right? Negative 1 times negative 6, we get positive 6. And to get to 10, that's not a minus, but to get to 10, it's going to be 4 plus 4. Is this just over with a remainder of 4? I have no freaking idea. Where is my phone? I was gonna look this up. Let me pause this for a second. Alright, okay. So check it out, right? I mean, obviously where the binomials are, it doesn't really matter where the binomials are, because I did it on Google, right? And, sorry, my my camera is taped to my lamp, so you can kind of see it reflecting. Can I get it in a way you can see it without it being reflected? Yeah. K minus 6 plus 4 over k minus 1. And although it is the same, I mean, yeah, okay, we have that over here. It's flipped. But these are binomials. So it shouldn't matter what orientation they're in, because they're going to cross multiply regardless, right? Like I said, I've never done this before. I never look at this. Look. I know it's all erased, but like that was me trying to do her strategy, right? And I didn't, I guess I did do it, I guess. Her strategy, I guess I copied down what she did from the board, but I didn't remember what she did. So I guess it was 4. I didn't see that until now. But, like, I just proved here that this works, right? That, my friends, calls for a victory brewski. Tastes like math.